Okay, let's dive right into this. Welcome to this explainer, where we're going to unpack a truly monumental shift happening right now in the world of technology. For a long time, we've kind of looked at AI as just some abstract code floating in the cloud, or maybe a simple text box on a screen. Well, scratch that. We are rapidly waking up to the reality that AI is becoming a massive, physical, nanosecond-driven manufacturing process. Today, we are talking all about the AI factory revolution. So, to wrap our heads around this transformation, we're going to hit 5 key areas. First up, enter the agentic era. Second, the nanosecond impatient agent. Third, architecting for zero latency. Fourth, the gigawatt AI factory. And finally, the extreme co-design mandate. Let's get into it. All right, section 1. Enter the agentic era. AI as a manufacturing workforce. The absolute crucial point to start with here is that we have to totally shatter our current, honestly, kind of outdated view of artificial intelligence. The paradigm shift we're seeing is just stark. Think about traditional generative AI as a highly capable librarian. You ask it a question, it goes into the stacks, retrieves the information, and hands you some static data. But that's the past. We are now moving to agentic AI. This is no longer a librarian. This is a skilled worker. It doesn't just fetch text anymore. It judges context, formulates complex plans, actually wields software tools, and autonomously manufactures finished products. AI has literally evolved into an autonomous manufacturing workforce. And because of this fundamental change in what the workforce looks like, our entire infrastructure has to change with it. Computing is no longer just a boring IT expense. You don't just shove some servers in a back room and write it off as a cost of doing business. Data centers are literally becoming revenue-generating power plants. In this new world, your capacity to generate AI tokens is directly equal to your capacity to generate revenue. $9 trillion. Let that scale sink in for a second. That is the sheer size of the stakes involved here. In generated productivity value. Tokens aren't just little fragments of data anymore. They are the actual raw materials of manufactured intelligence, and they are driving corporate and even national GDP. When your skilled worker operates at this kind of massive scale, the financial output is absolutely staggering. Which brings us right to section 2, the nanosecond impatient agent, continuous autonomous cognition. Let's take a look at how these new AI workers actually think and why their incredible speed changes absolutely everything about how we build computing hardware. So the engine of this autonomous cognition is what's called the agentic loop. Unlike a human who, clicks a mouse and sits there waiting, an AI agent operates in a continuous, lightning-fast cycle. It observes its environment, reasons through the logic, plans an executable sequence of steps, and then acts by triggering a tool. And the exact millisecond it acts, it observes the result and starts the entire loop all over again. Because these agents process this loop so rapidly, we actually call them impatient agents. And they are exactly that, impatient. They demand extreme, zero-latency execution. If an AI agent reasons out a brilliant plan and then has to sit there waiting for the computer hardware to catch up and load a tool, the entire workflow breaks down. They simply cannot tolerate delay. Just compare the timelines here. For a human operator, experiencing a second or two of latency while a web page loads is, well, it's an annoyance, right? But for an agent, latency is measured in nanoseconds. They are operating at light speed. So when an agent hits a traditional CPU that just can't feed it data fast enough, it hits a massive latency wall. In this new era, latency isn't an IT annoyance. It's a direct, measurable loss of manufactured revenue. And here is the real financial threat of that latency. We're talking about highly expensive GPU assets, the absolute brains of the operation. Every single microsecond that an agent is forced to wait on a bottlenecked legacy CPU means hundreds of millions of dollars in GPU infrastructure are just sitting there, completely idle. An idle GPU is a catastrophic negative ROI. It's just wasted capital. We absolutely have to eradicate this bottleneck to keep that token production flowing. So how do we solve this massive financial drain? Well, that's section 3, architecting for zero latency, re-engineering the silicon blueprint. We really have to look under the hood at how hardware is being radically re-engineered from the ground up to support these incredibly impatient agents. The solution actually starts right here, down at the microscopic level, with the Vera CPU. Now, this isn't your standard consumer processor. It was built completely from scratch specifically for these agentic workloads.
It features a really aggressive 10-wide decode engine, capable of decoding 10 instructions simultaneously, purely to prevent the kind of bottlenecking that starves a GPU. It's fully optimized for complex, impatient reasoning. By building this from scratch, they've successfully eliminated what the industry calls the chiplet tax, those tiny, frustrating delays caused when separate chips have to physically talk to each other across a board. Eliminating that physical gap guarantees instantaneous execution. And the business gain? It delivers up to 6 times faster real-time stream processing compared to legacy systems. Guys, that is the difference between an idle GPU and maximum token manufacturing.
And let's see how this builds out into the server rack itself. We used to rely on a legacy approach that meant hours of messy, highly vulnerable cable assembly. But now with the Vera Rubin midplane, they've eliminated those structural cables and hoses entirely. It reduces rack assembly to less than 5 minutes. Why does this matter so much? Because a faster setup means a faster time to first token, which drastically accelerates how fast you recover your massive capital investment.
Okay, so we've fixed the microscopic silicon, and we've totally cleaned up the server racks. Now, let's zoom all the way out. Section 4, the Gigawatt AI Factory, scaling intelligence to global grid levels. Let's look at the sheer macro scale required to house these incredibly fast, super power-hungry brains.
$100 billion. That is the capital investment required to construct just a single gigawatt-scale AI factory. When you are deploying that astronomical amount of CapEx, your margin for physical design error is absolutely zero. It has to work perfectly the very second you flip the switch.
And this is exactly what that $100 billion buys you. This isn't just a data center. It is a massive industrial-scale infrastructure completely optimized for compute-driven revenue. From the primary substation all the way down to the cooling infrastructure, every single square inch is purpose-built to support the continuous, unyielding operation of AI accelerator clusters. At this insane scale, every thermodynamic detail matters. They literally take the unpredictable, massive heat generation from the chips, and instead of just, blowing air over it, they cool it with 45 degrees Celsius warm water. They pair this with a technique called liquid power smoothing, which radically minimizes the energy overhead needed for cooling. And here is the absolute genius part. They reclaim that saved power budget to run even more revenue-generating GPUs within the exact same grid constraints. It is just a masterclass in efficiency.
Plus, these mega factories don't just passively drain the local power grid. Honestly, they're too big for that. Instead, they use dynamic load balancing to synchronize with live external grid signals. This transforms the whole AI factory into a flexible, cooperative global energy asset. They're out there negotiating power consumption in real time with renewable sources like solar and wind, driving down operating expenses while maintaining a totally sustainable integration with global power networks.
Which brings us to our final section, and really the ultimate business takeaway for navigating this whole industrial AI revolution. Section 5, the extreme co-design mandate, the future of enterprise architecture. Because the agentic loop relies on absolute nanosecond harmony across the entire facility, you just can't buy things piecemeal anymore. Treating the chip, the rack, the network, the power, and the cooling as separate, isolated purchases, it's a massive strategic error. It literally just leads you straight into an architectural dead end.
So the crucial point is summarized perfectly by this idea. To maximize profitability, enterprise buyers must purchase the integrated architecture, not just the silicon. If you go out buying cheap chips in isolation, it completely breaks those critical thermodynamic and data flow links between the layers. The cooling won't march the compute, the network is going to bottleneck the reasoning, and it will inevitably lead to a catastrophic long-term loss of revenue. Literally everything must be co-designed.
So I'm going to leave you with this final, vital question as we fully step into the agentic era. Take a hard look at your current roadmap. Are you truly building a unified revenue-generating power plant that's ready to manufacture intelligence at scale? Or are you just bolting together isolated chips and heading toward an architectural dead end? It's quite literally a multi-trillion-dollar question, and the time to figure out your answer is right now. Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.